Hello everyone, my name is Sajidur Rahman Siam, and today I am excited to introduce our research title, Machine Learning Approaches for Predicted Customer Subscription to Bank Term Deposits, a comprehensive analysis. The banking sector and especially the term deposit market plays a crucial role in providing financial stability. Term deposits represent a stable funding source for banks, and they offer customers a secure investment option. However, the traditional marketing strategies for term deposits such as telemarketing often yield very low conversion rates, typically hovering around 11%. This low conversion rate is both a challenge and an opportunity for improvement. This is where machine learning comes into play. By leveraging machine learning algorithms, we can better identify which customers are likely to subscribe to term deposits, improving their marketing efficiency, reducing operational costs, and ultimately enhancing customer satisfaction. For our study, we primarily use bank marketing dataset from the UCI Machine Learning Repository. This dataset is one of the most commonly used datasets in predictive banking applications. It contains over 41,000 customer records from telemarketing campaign conducted by a Portuguese banking institution between 2008 and 2010. One of the challenges with the dataset is the severe class imbalance. Only about 11% of the customers subscribe to a term deposit, making it a classic case for studying how to handle imbalanced datasets. In terms, the models used, researchers in this domain have experimented with a wide range of algorithms. Logistic regression, being simple and interpretable, often serves as a baseline model. Decision trees are also widely used for the interpretability, but they tend to overfit if not properly tuned, especially when the dataset is noisy. On the other hand, unstable learning methods like random forest and gradient boosting consistently outperform these simple models in terms of predictive accuracy, achieving results with accuracy rates typically above 85%. These unstable methods work by combining multiple weak learners to produce a more robust and accurate prediction. Naive-Bayes, a simple probabilistic model, is also often used in this domain. While it offers fast training and prediction times, it performs less effectively due to strong independence assumption it makes between features which often don't hold true in wild datasets. When we delve into literature, we also find consistent results in terms feature importance. Features such as duration of the last call, lineage, previous campaign, outcome, and the number of contacts made are consistently found to be most predictive for term deposit subscription. In summary, our review of the literature highlights that unstable and the tree-based methods are the most effective, but that positioning techniques such as handling class imbalance are just as important in ensuring the success of machine learning models. With this in mind, we aim to further explore how these techniques can be applied to optimize bank marketing strategies.
Thank you, Sajidur. Now let me take you through our methodology and results from our experiments. As mentioned earlier, we use bank marketing dataset, which contains combination of numerical and categorical features. These features describe demographic information such as customers' age, job, marital status, and education, as well as financial information like account balance, loan status, and whether they have a housing loan or not. Additionally, the datasets include campaign-specific details like duration of last call, month of the last contact, and the number of previous contacts made. The target variable indicates whether the client subscribed to a term deposit or not. Before we fed the data into the machine learning models, we took several important pre-processing steps. Firstly, we ensured that there was no missing values in the dataset. No imputation was unnecessary. Categorical features such as job type, marital status, and education were converted into numeric format using one-hot encoding. For numeric features like age, balance, and duration, we applied scaling using standard scalar to ensure features had a similar scale, which is important for models like logistic regression. One of our biggest challenges in working with this dataset is the class imbalance, as only 11% of customers subscribe to term deposit. To mitigate this, we applied stratified sampling during training test split. This approach ensures that both the training and testing sets have the same proportion of positive and negative instances as in the original dataset. We then trained and compared 6 different machine learning models: logistic regression, decision tree, random forest, gradient boosting, AdaBoost, and naive Bayes. For each model, we counted hyperparameter tuning using research CV with 5-fold cross-validation to optimize the model settings. Now let's talk about the results. We found that ensemble models, specifically random forest and gradient boosting, consistently outperform the simple classifiers. These models provided the best balance between precision and recall, which is crucial for real-world marketing applications for both false positive and false negatives carry significant costs. Logistic regression, while not quite as powerful, performed competitively and was preferred when interpretability was a key requirement. Decision trees, true interpretable, performed slightly worse, and naive Bayes showed the weakest results due to its assumption of feature independence, which didn't hold in our dataset. AdaBoost, on the other hand, performed better than naive Bayes but still lagged behind random forest and gradient boosting. One particular interesting finding came from our feature importance analysis using the random forest model. The duration of the last contact emerged as most important feature in predicting whether a customer would subscribe to a term deposit or not. Following that, features such as client age, imbalance, and number of previous contacts also play significant roles. Thank you.
Thank you, Ifaz. Now I am Siam. I will carry on my part. First of all, uh, to conclude, this study confirms that assembles methods, particularly random forest and gradient boosting, are the most effective algorithms for predicting customer subscription to the bank in terms of deposits. These models consistently outperform simpler classification like logistic regression, decision trees, and neighbors in terms of accuracy and predictive performance. The pre-processing steps we employed, such as one-hot encoding for categorical variables, scaling for numerical features, and stratified sampling to address class imbalance, played a crucial role in ensuring that the models were robust and reliable. Additionally, our feature importance analysis provided valuable insights into what drives customer subscription decisions. Call duration, client age, and previous campaign outcomes were the most predictable and predictive factors. Our work makes several contributions. First, we provide a systematic comparison of 6 popular classification methods for this problem. Second, we validate the importance of proper pre-processing and feature engineering in achieving strong model performance. Finally, we highlighted the key features that banks should focus on to improve their marketing efforts and reduce unnecessary costs. Looking forward, there are several exciting avenues for future research. One potential direction is exploring deep learning techniques, which have shown promise in many domains, to see if they can offer even better performance for structured data like this. Another interesting direction is the application of real or online learning systems that could adapt to changing customer behavior over time. Furthermore, incorporating additional data sources such as digital marketing data and social media interactions or customer feedback could significantly improve models' accuracy and help banks tailor make marketing strategies even more effectively. Finally, the application of the explainable AI techniques would not only improve model transparency but also help in gaining regulatory approval and ensuring customer trust in automated marketing systems. In practical terms, we recommend that banks start the assemble classifier like random forest or gradient boosting as strong baselines. Investing in high quality pre-processing pipelines and establishing a robust model, retaining and evaluating framework will be essential for maintaining performance over time and adapting to shifts in customer behavior. In conclusion, machine learning is a transforming the way bank approaches marketing by leveraging powerful as ensemble methods and implementing solid pre-processing techniques. Financial institutions can significantly enhance their marketing strategies, reduce operational cost, and improve customer satisfaction. That's all from our part. Again, I am Siam Noor, and we are from Group 2. Thank you all.